Hello, in this video we will discuss about the hypoglycemia in type 1 diabetes. So what is type 1 diabetes? We will also learn about that. And we will just understand about the autoimmune disorders because the type 1 disease is due to the autoimmune disorder. So first of all, we should learn about the insulin and glucagon. So insulin is anabolic hormone released from pancreas stimulate glycogen, fat store, proteogenesis. So in this way, all thing is the anabolic, and in this way, the synthesis of the larger molecule due to the insulin. While the glucagon is opposite as compared to the insulin because it is catabolic hormone, also released from alpha cell, but the insulin released from the beta cell of pancreas and the alpha cell of pancreas to stimulate the catabolism. So in this way, when insulin will be decreased, so the glucagon will be increased. So antagonistically work, and insulin when increased, so the glucagon will be decreased. In the normal person, the glucagon will produce during the fasted state, while the insulin will produce from the fat state because the hyperglycemia will be converted into the hypoglycemia due to the sugar will enter into the muscle as well as other tissue. So this is the person which that's contain pancreas is here, which that is attached with the duodenum, and this is the blood circulatory system of the person. So when the hypoglycemia will be occur, in this the hypoglycemia is due to the decrease of the glucose will lead to will lead to the peripheral sensors will sense this hypoglycemia will lead to target to the brain as a signal. After the brain, here is the pancreas contain different type of cell in the form of islet of Langerhans cell. This is the endocrine cell, alpha cell, beta cell and delta cell. Alpha cell produce glucagon, beta cell insulin and delta cell produce somatostatin. So in this case here we will just learn about the beta cell and alpha cell. So here the peripheral nervous system will target to the pancreas with the beta cell for when bind with the neurotransmitter. After this binding it will lead to trigger the production exocytosis of the vesicle, for example glucagon as well as insulin on the basis of requirement. So in this way the beta cell will be decreased. The damage of the beta cell in the type 1 diabetes will lead to increase the alpha cell production of glucagon because the hypoglycemia. If the hyperglycemia will occur, so the target to the beta cell, if the normal beta cell lead to produce insulin for decreasing the glucose level in the blood. So here is the increase in sympathoadrenal outflow SNS. In this way lead to increase the norepinephrine lead to palpitation, tremor and arousal. While increase the acetylcholine will lead to due to the sweating and hunger. So will cause the sweating and hunger. In this way, the both hormone will lead to increase the neurogenic symptoms, often attenuated uh, in type 1 diabetes mellitus. So in type 1 diabetes mellitus, this increase the norepinephrine, the palpitation, tremor and arousal. While increased acetylcholine neurotransmitter will lead to sweating and hunger. This increased neurogenic symptoms often attenuated in type 1 diabetes mellitus. So it will target to the gastrointestinal tract will lead to increase the ingestion of carbohydrates. Why? Because in the blood circulatory system the glucose level will be low, is known as hypoglycemia. And in this way the increase the glucose into the blood circulatory system as well as increase the glucagon also when the hypoglycemia will be occur. So the glucagon will also target to the different tissue. For example, the here is the liver. First we will discuss here. when bound with the liver receptor, with the glucagon receptor, will lead to different mechanism. So in this way we will just understand with simple um, diagram: increase to gluconeogenesis, glycogenolysis, and in this way here is again the gluconeogenesis and glycogenolysis will lead to increase the hyperglycemia, will lead to increase the glucose level. So remember, the ingestion of the glucose will be more, and the catabolism from the liver muscle will be increased, will lead to increase the blood glucose level for normal isoglycemic effect rather than the hypoglycemia. And in this way, on the other hand, here you can see the type 1 diabetes is the autoimmune disorder. Let's begin to understand, in which the beta cell will be collapsed with antibody. So here you can understand with different. In this way, the T regulatory cell will not regulate, and in this way, the misunderstanding as an antigen, beta cell antigen, will target the CD4 positive cell. Will after the antigen presenting cell as a beta cell, will recognize the antigen, and after this, the naive CD4 T cell will be mature, will containing antigen. Antigen for what? About the beta cell. So about the beta cell, in this way the beta cell basically containing antigen will target to the antibody containing B cell, naive B cell. And in this way the CD4 T cell, which that is show the antigen through MHC class 1 molecule through antigen presentation. So the antigen presenting molecule, which that is present the antigen via a B cell with antibody. After this recognition, the B cell will proliferate to produce two type of cell: plasma cell and B memory cell. Here is the plasma cell and B memory cell. This basically plasma cell will produce often plasma cell produce antibody, which that will be against the B cell and collapse the B cell through antibody. Will opsonization and necrosis will be occur. So the cell death will be occur. And remember that this is the basically autoimmune disorder. For prevention of autoimmune disorder, naturally the T regulatory cell will regulate and prevent the antigen recognition through CD4 positive, and that will be education to the CD4 for our body prevention of antigen presentation or antigen detection. So here you can see this is the another thing. This is the basically adrenal medulla, and in this way the adrenergic neuron, which that is present in the adrenal medulla of the adrenal gland, which that will target, and in this way the sympathetic nervous system, the adrenal medullary cell, will lead to produce the epinephrine fast, quickly, and in this way the epinephrine will increase, will target to the different tissue, for example kidney, adipose tissue, and skeletal muscle cell, adipocytes, and kidney. So in this way, what is the mechanism for this? Basically, kidney when bound with the epinephrine will lead to decrease the glucose clearance and increase the glucose into the blood. Adipose tissue when bound with the epinephrine will lead to lipolysis to produce fatty acid and glycerol, while the skeletal muscle when the epinephrine will bind the sympathetic nervous system as a catabolic nervous system, will lead to increase amino acid, fatty acid, and lactate, glycerol. So in this way, this all things the catabolism and catabolic product, which that is catabolism, the larger molecule will convert into the smaller molecule. So in this way, the glucose and fat, and on the other hand, the glycogen, glycerol, which that is late converted into the ketones. This is the ketone body, is known as ketogenesis. The production of ketone body is the beneficial for us due to the energy alternative pathway, will lead to ketoacidosis and cause the complication due to the decrease of the blood pH. But the ketone is the one and most major function for the survival. On the other hand, increase the glycogenolysis will lead to increase the hyperglycemia, so increase the blood glucose level. I hope you make sense. Please make sure to subscribe.